In this video, I'm going to be determining the determinant of this matrix using the cofactor and the minor approach. Now, stick with me. I'm going to be identifying the minors, and at the end, we are going to be using the minors, let's say, to get to the cofactors. So out of that, that's why I'm giving this a name of cofactor and minor approach. Now, with the cofactor and the minor approach of determining the determinant of a matrix, of course, in this way, we shall be determining the cofactors. At the same time, we shall be identifying the minors, and then we shall use this approach to determine the determinant of this matrix A. Now, in this case, if you look at this, now, if I am to determine the cofactors of this matrix, right? Now, that means at the end of the day, I have to, let's say, identify the minors, of which in this case, that if I choose an element from this matrix, for example, that if I choose, let's say from here, I'm having, for example, if I choose like, if I have this one, right? Now, after choosing that one, in that case, let me choose a different pen here. Let me use this. And let me change a bit of color here and use white. I think to be better. So you find that if I choose like one here, let me remove this. If I choose this one right here. Now, if I choose one, that means that for me to get the minors, the minor matrix, I'll have the 0, 1, 3, 4. In the way that if I choose one, that means in this case, I'm going to be, let's say, eliminating this row, that I'm not going to use that row, and I'm not going to use the column that's containing this element. In another way, if I choose 2, right, that means that if I remove this, that if I choose 2, that means that I'm going to eliminate the row that's having the 2, and the column as having the 2 in either way to get the minors. So that means that the minor matrix, when I chose, well, in case I choose 2, that means that I'm having 3, 1, 3, 4, like that. Now let's see it in the working. So out of this, if I am to determine, let's say like the cofactor of 1 in this way, how am I going to go about it? So you find that in this case, I'm going to come here and say that, let me see, let me use here. Now out of that, I'm going to come here and say that the cofactor of 1, I'm going to say, now let's compare this matrix to, let's say A, 1, 1, A, 1, 2, A, 1, 3, A, 2, 1, A, 2, 2, A, 2, 3, and then A, 3, 1, A, 3, 2, A, 3, 3. Now we are comparing matrix A to this, right? Just comparing to guide us when getting the cofactors, right? Now, let's get the cofactor of 1 in this case. So I'll consider that 1 is in this position. So having known that 1 is in the position of A11, now what we are going to do to get the cofactor, for example, of that 1, you're going to say cofactor 1, 1 corresponding to that A11. So this will be equals to, we're going to say negative 1. What we are going to do now, you add, right? Now 1 plus 1, you're going to have 1 plus 1 giving you 2, right? And of course, if we are to form a minor matrix, remember I told you that since A11 is in the first row, we eliminate that row. At the same time, we eliminate the column that is having that. We eliminate the column that's having that. Then at the same time, now we take our minor matrix to be having A22, A23, A32, A3, 3. That means that up here, if I'm to check, I'm going to be having 0, 1, 3, 4, right? So I'm having 0, 1, yes, 3, 4. Now, the symbols, the bars that I'm using at the end of the elements, I'm just meaning that I'm going to be getting the determinant of the minor matrix, of which in that case, so my minor will be equals to -1 squared, it is still 1, into, now 0 times 4, I get 0, right? Then minus 3 times 1, I'm getting 3. You close this, right? So I'm going to be having something that's equals to, I'm going to be having, this is -3, of which at the end of the day, I'm having -3. Now that's the cofactor of 1, right? Now let's get the cofactor of 2, of which the cofactor of 2, which is in C1, 2, which will be equals to -1 power. Now 1 plus 2, you're going to get 3. Then we want to form the minor matrix. Now we are taking this, we are on this, right? We're on 2, of which here, now we are going to take, in this case, if you look at this, let me mark this out. Let's say, let me use yellow. If you look at, if I pick, now I'm getting the cofactor of 2. That means that I'm going to take this, that we are taking out now. We are eliminating this and that, right? So we're having 3, 1. We are going to be having 3, 1, right? At the same case, we are going to be having 3, 4, right? So we're having 3, 4. So out of that, we are going to say this is -1, -1 to power 3, we are going to get -1 into, now 3 times 4, we're getting 12, right? Minus 3 times 1, we are getting 3. So that means that here, if you subtract here, we are having 9. 9 times -1, we're going to get -9, right? Now let's get the cofactor of 0, right? Of which, now I know it is 0, but let's get it, right? So C1, 3, which will be equals to -1 to power 1 plus 3, you're going to get 4. Now let's form the minor matrix in this case. So that means that if you look at this, let me remove this. Let me remove that, and let's, now we are forming the minor for 0, right? So that means that we are eliminating this, and where there's 0, that means that I'm having only that, right? So we're having 3, 0. You're having 3, 0. You're having 3, 0. After having 3, 0, we are also having 3, 3. So we're having 3, 3. Now let's get the cofactor. So we are going to have, this is going to be 1 into 3 times 3, we are getting 9, minus 0. Close that. So we are going to have here something that's going to be 9, of course, of which is like, this is the cofactor in this position of, let's say, A1, 3, right? So now let's go to 3. Allow me, let's see, so let's get it from here. Now let's get the cofactor of this 3, right? So now through our comparison, the 3 is in the position of 2, 1. 2, 1. Now let me remove the so C, if you look at C, 2, 1 will be equals to -1 to power, this will be 3. Let's form now the minor matrix of this. Now remember, we're going to come here, we are going to, let's say now we are on this 3, right? So that means that we are eliminating this row, right? And column. So the minor matrix, we are going to be having 2, 0, and then 3, 4, right? So out of that, what you're going to be having here, this is going to be equals to, you're going to have, this is going to be negative 1 into, now 2 times 4, you're going to have 8. Then minus, now 3 times 0, you're going to be having 0, of course. Now that means that this is equal, you're going to be having, so this is going to be negative 8. So then let's go to now 0. Now with the 0 is a, let's say like it is the A. Let me first back this. If you look at 0 here, we are having, it is in A22, right? So that means that C 2 equals to negative 1, we are having it to power 4, because 2 plus 2, having it 4. Now let's have it here, let's form the minor matrix, right? So we're going to come here and say that we are going to eliminate this row, right, and this column, right? So what we are going to be having is 1. We are going to be having, in this case, we are going to be having 1 0 1 0 in that case, and then 3 4. We're having 3 4. So that means that here I'm going to be having something that's going to be, now if you look at negative 1 to power 4, I'm going to get 1 into 1 times 4, I'm going to be having 4, minus 3 times 0, I'm having 0. So that means that my cofactor in this case, I'm going to be having, this is going to be 1 times 4, I'm going to be having 4 in that case. Now let's go to 1. Okay, so 1 is in the position of, let's say we're going to say that's C 2 3, which will be equals to negative 1 to power 5. Now let's form the minor matrix for 1. Let me remove this so that we can identify easily. Now if you look at this, this is 1, right? So that means that we are eliminating this row and this column. That means that the minor matrix is having 1 2, you're having 1 2, 1 2, and then 3 3, right? So then that means that this will be equals to, we're going to have here negative 1 into, now this is 3 minus 6. So that means that this will be equals to, we're going to have, this is going to be negative 1 into negative 3. So that means that this will be equals to 3, right? Then that will be done. Now let's go to one more, and now we are going to the last row, which in this case we are having 3 3 and 4. Okay, now that will be C, you're going to be C 3 1, which will be equals to negative 1 to power 4. Then let's see the minor matrix in this case. Now since we are on this, what you're going to do, we're going to eliminate this row and the column. So we are remaining with 2 0 and 0 1, 2 0 and 0 1. So 2 0 0 1. So that means that this is going to be equals to 1 into 2 minus 0. So in that case, we are going to have something that's going to be equals to 2, which is perfect. Now let's go to C 3 2. cofactor C3 2. Remember, we are comparing, right? Let's do it from here. Now C3 2 will be equals to -1 to power 5. Now what's the minor matrix? Let's look at this. Now our minor matrix in this case, if you look at this, now we are on this. Let me first remove this. We are on this, right? So that means that we are eliminating the whole of that row and the whole of that column. So we are having 1 0 and 3 1. 1 0 3 1. Okay, so we are having 1 0 3 1. I hope you're correct. Check here. 1 0 3 1 1 0 3 1. Okay, so we're on track, right? So we're here. So we are going to say this will be equals to, we are going to have -1, right, into 1 minus 0. Close that. So this will be equals to, we are going to have -1 as our cofactor in this case. Now, next, let's have the last one, which is going to be C3 3. So that means this will be equals to -1 to power 6, right? Now let's have the minor matrix, of which if I remove this, and we are here on 4, right? So that means that we are eliminating the whole row and the column that's containing that element. So we are having 1 2 3 0, 1 2 3 0. So we are having 1 2 3 0. So that means that this will be equals to, so that means that this is going to be 1 into, we are going to have, this is going to be, so 1 times 0, you're going to get 0. 0, this looks like a 6. And this is going to be, we are going to have 0 minus 6, right? So that means that I'm going to be having something that's going to be equals to, I'm going to be having here, now 1 times -6, we're going to have -6. Now the last thing that we should be doing is to form the cofactor matrix of A, right? So the cofactor the cofactor matrix of A, right, will be equals to, now let's form this. So we are going to bring them in their order, right? So that means that if, let's say, the first cofactor we had was -3 followed by -9, right? Was -3 and -9, right? So I'm having here -3, -9, right? Let's see. So -3, -9, then we had 9 itself. So here we had also 9. Then after having 9, then we went to -8, 4. Had -8, -8, 4, -8, 4, 3 2, 3 2, -1 and -6, right? Now for me to get the determinant of A, in this case, what I can do, and from this I can get the first cofactors, right? Now these are the cofactors, the first ones in the first row, right? Now I multiply them by the elements of the original matrix in the first row. Yes, so I can say that -3, like the determinant of A, would be equals to, I would have here -3 into A 1 1, right? Then plus -9 into A 1 2, plus 9 into A 1 3. Or I can also say that I can also say let's say -3 into, if you look at this, into A 1 1 1, right? Now plus -8 into this will be A 2 1, right? Because I'm going downwards like this. Like this, I'm going downwards from here up to here, right? So -8 into 2 1, then 2 plus 2 into A 3 1, right? So either way I get the same answer. Let's try to find out. So out of that, for the first one, let's say for this, for 1, let's say I say that -3 into, of which our A11 from the original matrix, right, was 1. So 1, of which this is 1, then plus -9 into, I think this is 2. Let's find out, which is 2. Then I'm having then plus 9 into 0, right? So here I'm having -3 minus 18, right? So this gives me a -21 as the determinant of A, right? Now let's try using, let's say the second one. So this is the second one. That now from this I say that we're having -3 into A11, of which our A11 from our comparison, A11 is 1. So here we would have A11 as 1. Now minus 8 into A21, of which our A21 is 3. A21 is 3. Right? Now let's have here, then I said plus, we had here plus 2 into A31, which our A31 was also 3. So we're having here 3. So if you look at this, this is going to be -3, right? Minus, this is going to be, if you have this, this is going to be 24. and also plus 6, right? Now if you look at this, if let's say now negative 24, now if you look at negative 3 plus this, I'm going to be having 3, right? Plus 3. And if you add this, you're going to get negative 21, right? So either way, you get the same answer, right? So that's how you can get the determinant of a matrix using the cofactor minor approach. So very simple, just follow the steps systematically. Thank you for watching. See you in the next video.